Today's day 18 of Advent of Cyber, and today's challenge is called Lumberjack Lenny Learns New Rules. Compromise has been confirmed within the best festival company infrastructure, and tests have been conducted in the last couple of weeks. However, Xanta's SOC team wonders if there are methodologies that would help them perform threat detection faster by analysing the logs they collect. Elf McSkitty is aware of Sigma rules, and has tasked you to learn more and experiment with threat detection rules. Threat detection. Cyber threats and criminals have advanced tactics to ensure that they steal information and cause havoc. As you have already seen through the previous days, there are many ways in which this can be done. There are also ways for security teams to prepare their defenses and identify these threats. What would be evident is that most of the blue team activities will require proactive approaches to analysing different logs, malware, and network traffic. This brings about the practice of threat detection. Threat detection involves proactively pursuing and analysing abnormal activity within the ecosystem to identify malicious signs of compromise or intrusion within a network. Elf McBlue obtained logs and information concerning the attack on the Best Festival Company by the Murder Yeti. Through the various analysis of the previous days, it was clear that the logs pointed to a likely attack chain that the adversary may have followed and can be mapped to the unified kill chain. Among the known phases of the UKC that were observed include the following. Persistence. The adversary established persistence by creating a local user account they could use during their attack. Discovery. The adversary sought to gather information about the target by running commands to learn about the process and software on Xanta's devices to search for potential vulnerabilities. And execution. Scheduled jobs were created to provide an initial means of executing malicious code. This may also provide them with the persistence or be part of elevating their privileges. The attack chain report includes indicators of compromise and necessary detection parameters, as listed below. Additionally, the attack techniques have been linked to the MITRE attack framework for further reading. So the attack techniques within the MITRE attack framework which were used were account creation, software discovery, and scheduled task. Before we proceed to the next section, deploy the attached machine and give it up to 5 minutes to launch its services. So I'll do that now, and I'll be back when it's done. Okay, so everything's loaded, and in the attack box I have gone to the IP address of the challenge machine. So let's continue. So the attack machine has a Sigma application which constitutes the following features. Run, which you can submit your Sigma rule and see if it detects the malicious IOC. Text editor, which allows you to write Sigma rules in this section. Create rule, which allows you to create a Sigma rule for the malicious IOC, and vlog, which allows you to view the details associated with the malicious IOC. Chopping logs with Sigma rules. Sigma is an open source generic signature language which allows you to describe log events in a structured format. The format involves using a markup language called YAML, a designed syntax that allows for quick sharing of detection methods by security analysts. The common factors to note about YAML files include the following. YAML is case sensitive. YAML files should have the .yml extension. Spaces are used for indentation and not tabs. Comments are attributed using the hash character. Key value pairs are denoted using the colon symbol, and array elements are denoted using the dash character. Sigma makes it easy to perform content matching based on collection logs to raise threat alerts for analysts to investigate. Log files are usually collected and stored in a database or a SIEM solution for further analysis. Sigma is vendor agnostic, therefore the rules can be converted to a format that fits the target SIEM. Sigma was developed to satisfy the following scenarios: to make detection methods and signatures shareable alongside IOCs and YARA rules, to write SIEM searches that avoid vendor lock-in, to share signatures with threat intelligence communities, and to write custom detection rules for malicious behavior based on a specific condition. Sigma rules are guided by a given order of required optional fields and values that create the structure for mapping needed queries. The attached image provides a skeletal view of the Sigma rule. Let's use the first attack step challenge to define the syntax requirements. Fill in the details into our skeletal rule and detect that creation of local accounts using the text editor section of the SigHunt application to follow along. So title names the rule based on what it's supposed to detect. ID, a globally unique identifier that developers of Sigma mainly use to maintain the order of identification for rules submitted to the public repository, found in UEID format. Status describes the stage in which the rule maturity is at while in use. There are 5 declared statuses that you can use. Stable, the rule may be used in production environments. Test, trials are being done to the rule and could require fine-tuning. Experimental, the rule is very generic and is being tested. Deprecated, the rule has been replaced and will no longer yield accurate results. And unsupported, the rule is not usable in its current state. Description provides more context about the rule and its intended purpose. Here you can be as detailed as possible to provide information about the detected activity. So this is an example one for suspicious local account creation. Sigma rule. Log source describes the log data to be used for the detection. It consists of other optional attributes. Product selects all log outputs of a certain product type. Examples are Windows and Apache. Category, select the log files written by the selected product. Examples, firewalls, web, or antivirus. Service, selects only a subset of the logs. Example are SSHD on Linux or security in Windows. Definition describes the log source and its applied configurations. So you got log source, and then inside log source, that's the product and the service. Detection. A required field in the detection rule describes the parameters of the malicious activity we need an alert for. The parameters are divided into two main parts. The search identifiers are the fields and values the detection should search for, and the condition expression sets the action to be taken on the detection, such as selection or filtering. The critical thing to look out for account creation on Windows is event ID associated with the user's account. In this case, event ID 4720 was provided for us on the IAC list, which will be our search identifier. So you got detection, selection, and then the event ID, which is an array which has one item of 4720, and the condition for this is to select it. The search identifiers can be enhanced using different modifiers appended to the field name with a pipe character. The main type of modifiers are known as transformation modifiers and comprise the values contains, ends with, starts with, and all. Some of these modifiers will be vital in writing rules against the other ISCs. So this is a detection rule where you're trying to select an image that ends with /service_host.exe, and you're searching for command lines which contain all. So it contains all, so the command line must contain --exe and -c. False positives, a list of known false positives that may occur based on log data. Level describes the severity with which the security team should take the activity under the written rule. The attribute comprises 5 levels: informational, low, medium, high, and critical. Tags adds additional information that can be used to categorize the rules. The common tags are associated with tactics and techniques from MITRE ATT&CK framework. Sigma developers have defined a list of predefined tags. So false positives unknown, its level is low, and the MITRE ATT&CK tactics are persistence, and the technique is T1136.001. We have written our first Sigma rule and can run it on the AOC Sigma hunting application to see if we can get a match. As mentioned before, Sigma rules are converted to fit the desired SIEM query. In our case, it should be known that they are being transformed into elastic queries on the backend. Various resources perform this task, with the native tool being Sigmac, which is being deprecated and replaced with a more stable Python library, PySigma. Another notable tool to check out is Unicoder.io. It's an open source web Sigma converter for numerous SIEM and EDR platforms. It is easy to use as it allows you to copy your Sigma rule on the platform and select your preferred backend application for translation. So let's give that a shot, where we will create the Sigma rule. Let me zoom in here. Challenge 1, suspicious account creation. We'll create the rule, and then we will grab the details we had in here. So let's copy this. So that was title, ID status, and description. So let's copy and replace that. Oh, my bad. So let's copy this, and then let's paste it, put it into our TagBox clipboard like so, and then we can paste it here. And let's do that for the rest of these. Okay, so we've filled in all the information for the local account creation. Let's run it and see if it does anything. So successfully detected suspicious local account creation. And we've got the flag here, THM, not just your user. So let's copy that. We'll scroll to the bottom where we can put the flags in, right here, submit, and let's continue. So activity. Equipped with the knowledge about Sigma rules, your task is to complete the remaining 2 challenges by writing rules corresponding to the attack chain phases and IOCs. Santa is relying on you to beef up his security against adversaries attempting to stop Christmas this year. As a reminder, the required fields for the attacks are below: software discovery, category ID, event ID, image command line, and scheduled jobs, same thing. So I've put in the first one. Now let's look at the log for it. So over here we've got view log. Okay, so we've got Bandit Yeti Mini, Sam account name. I think that's what it's looking for. Yep, that was it. Okay, so now on to the second challenge. So this one, software discovery, we can go back to the top here. We can go back to here and create Sigma rule based on this. So if we go to here, create rule. So this has an event ID of 1. Let's see how it's formatted. Okay, so let's copy this and let's put it in. Okay, so image ends with reg.exe, so let's type that in. The service is sysmon. The category is process creation, and the command line is it must contain reg query, and it must contain hkey local machine software. Need to put that into here. Okay, let's run this and see if it's all good. Invalid YAML syntax over here. Okay, this needs to be 1, 2. I think that's all good. Now let's run it. Sigma rules to specific. Okay, so we'll get rid of that registry location. Now let's run it. To generic, required filter /v. Okay, so that'll be here. /v. And does it want service version as well? No hits found. Oh, it should be like this. Selection. Now let's see if it works. There we go. So THM, what is running here? So copy that and we'll put that for flag 2. What was the user's path in challenge 2 log file? So if we go back and view the logs. So user's path. So Sigma AUC 2022 Bandit Yeti. Okay, now on to flag 3. Okay, so I'm just going to copy this, create rule for challenge 3, and then I'm just going to paste this back in. So then we don't have to rewrite a bunch of it. So let's look at the rules for this. So schedule task, this is process creation. Event 1, sysmon, that's schedule task.exe for the image. SCH tasks, parent image. Not sure how parent image fits into here, or how you write it. See if there's any examples for it. Nope, that's any instance of parent. So we'll keep that out for now, but we will put the task in here. So SCH task /create, and let's see if it likes that. Yep, so that worked. THM schedule on point 101. So that is flag 3, and we now need to find the MD5 hash for this log. So let's go to here, view log, see hashes over here, and that is this string. So we can copy that, paste that into here, and that is day 18 of Advent of Cyber completed. If you liked this video, make sure to like and subscribe.